So welcome to our Sunset Learning Tech Talks. My name is Russell Hughes. Nice to meet you guys. So we're going to go through and discuss a few different things about the SD-WAN, and what we're really trying to get familiar with is kind of a big picture look, and then what are the different components that allow us to be able to support the idea of an SD-WAN environment. Okay. So they show what's really going on here, right? The WAN really kind of evolving quite a bit, right? Where it used to be rarely used and we didn't need a whole lot of bandwidth, now you're seeing those WAN connections being much, much more involved and more used as well. When you start talking about things like, it's not just about how we get from the branch office to the corporate headquarters, but how we get to the data center, how we get to things like cloud computing that we're utilizing. So a lot of these applications are adding to our WAN bandwidth that we have. And where we used to have things like, if, for instance, you had an MPLS cloud and an internet connection, right? Anything that goes back and forth between my branch office and corporate headquarters typically went through that MPLS cloud, right? And only if that MPLS cloud goes down would you bring up then a VPN tunnel through the internet to be able to communicate back and forth between those two offices. So what we're trying to do here is to say, rather than having that situation of an active standby type of scenario, now we're looking more for an active scenario. Okay, how can we send traffic across both of those physical links at any given time and really still maintain quality of service for that traffic as well? One of the big things that we're going to be looking for. So all of this information is going to be added to us here to determine what's happening. Now, they mentioned the idea of this concept of an overlay and underlay network that they have on this particular slide. So I see a lot of people have kind of an issue with what the heck is an overlay network. Well, you kind of think about it, I always think about it as like a VPN type of connection, okay? So think of just simply internet access that we have available for us, right? From site 4 to site 3, in this case, we've got communication. We can send data across the internet back and forth between the two. Right? And that internet and the actual physical routing of that traffic that we go through would be what we would consider our underlay network. How are we physically connected together, essentially, that we're looking for? Right? So we got public addressing that we're communicating through this public internet to be able to reach the site on the other end. We then bring up a VPN tunnel so that we can secure that traffic back and forth. And if you think about the idea of when we bring up this VPN tunnel here, so when we deal with the idea of creating this VPN tunnel between site 3 and site 4 in this case, what we're doing is that tunnel essentially has an IP address on both sides, okay, that we use typically a part of our private network that we're dealing with. And then we encapsulate all the data from site number 4 to site number 3 with a new transport header, right? The source IP address being the physical IP address of site number 4, and the destination being the physical address of site number 3 on the other end. Okay, so essentially that VPN tunnel is an overlay on top of internet routing that we're looking for. Okay, we're just extending that concept a little bit more to be also be able to do that through an MPLS cloud. Okay, whereas before an MPLS cloud, we just simply sent data out back and forth between these two sites. What we're going to see now is, again, we're going to bring up a VPN tunnel across that link. Right? So we're going to have a VPN tunnel from one location to another location. I've also got then a VPN tunnel. I'm going to do this in red as well. I've got a VPN tunnel through the internet to be able to reach this location on the other end. Okay? So I've got essentially two paths that we're going to see as equal cost path. Load balancing across that link. Now what you're going to see, once we have those tunnels up and running, we're going to verify the health of those tunnels by utilizing what they call bidirectional forwarding detection. So BFD, in this case right here, sends out small hello messages, and I'll get back and answer in the other direction. And what that's going to give me with these hello messages is not only is the link up and running, can we send traffic through that particular tunnel, but it'll give me statistics about things like delay statistics, packet loss statistics, jitter statistics that we have on that network, and give me what they would call a quality of experience number that we're utilizing. And that QoE number that we get is essentially the health or the how good is that circuit that we're utilizing through the MPLS cloud? And we're also going to do that same thing out over here through the internet, right, with BFD messages back and forth between the two to judge the health of that particular connection. We're eventually then going to create policies on our edge devices over here at these different sites to say, based off of this type of application, I require this quality of experience. And if that tunnel can't give me that quality of experience, look for another tunnel that can. Okay, so it's somewhat similar, almost, if you guys have ever played around with things like traffic engineering and MPLS, it's very similar to that. The idea that we need to have specifics within here. Now, the big difference being is that we don't have any kind of RSVP information that's going through this guaranteeing that tunnel back and forth. So I'm constantly got to check that tunnel with these bidirectional forwarding detection information to see what the health of that tunnel is. Okay. Now, in a default environment, what you're going to see happening is we are going to create these tunnels from one location to another location. I've got multiple tunnels that are going to be automatically created in this case. I'm going to create a tunnel through the internet to get to this site and a tunnel through the MPLS site cloud to get here. I'm going to have a tunnel to get through the MPLS out over in this direction and a tunnel to get through the internet to get to site number 2. I'll have a tunnel through the MPLS cloud to get to site number 4 and a tunnel through the internet to get to site number 4. Okay. All of these devices connected together in essentially a full mesh environment through both of our transport networks that we have. And that creates the overlay that we're discussing, these tunnels going across this link. Okay. And we need to know what is the best tunnel to be able to send certain types of data. Now we can go through and say, hey, I've got all of my data and just here's what I want you to do for all my data. Okay, split it up in half and go through and try and load balance across those links. But more likely what you're going to see is that we've got certain applications that we're going to match in our policy. Right? When it's a voice application, I want that only sent through the MPLS cloud. Okay. If it's a video application, we might go through and say, send it through the MPLS cloud, and if that's not available, then use the internet. If it's just general like file transfer, we might say use the internet connection first, and if that's not available, then use the MPLS cloud. Right? And so when we go through and set up this SD-WAN, it's not just about the availability to be able to create these tunnels back and forth. How do we secure it, right? So we got to go through and send out what kind of encryption we're going to use, what kind of key values are we going to use back and forth. That's all going to be automatically propagated based off what we configure in the SD-WAN environment. Okay? And how do we get from one location to another location? Now, important to recognize a couple different things within here. Each one of these edge devices that we're dealing with at these sites will have what we call a system ID. Now, that system ID is an IPv4 address, so it's a 32-bit dotted decimal address. Usually it's going to be someone's loopback address that you're going to be utilizing as your system ID. And each edge device has its own unique system ID everywhere. Okay? Eventually, then what we're going to do is we're going to go through and say, I can reach that system via multiple transport IP addresses. You can get here via the MPLS IP address that we have and the public address that we have on my internet connection. And these are going to be sent off as what they call TLOC routes, okay, or transportation location IDs, okay. You're essentially saying you can reach the exact same router, this system ID, via multiple IP addresses depending on which link you're going across. If you're going across the MPLS cloud, it's this IP address. If you're going across the internet, it's a different IP address. But both of them get you to the exact same physical router that we got available out over here. So we're going to advertise that information from edge router to edge router. Okay? Now what you're really going to see is that it involves another device, what we call our vSmart controller, which is really the control plane that we're going to utilize. I'm eventually then going to advertise what we call service routes. And the service side would be the inside network that we've got out over here. If I've got another router and there's another subnet, these subnets out over on this side are what we call our service side routes. And they're going to be advertised. To get to those subnets, you need to reach the system ID. Well, how do I get to that system ID? Well, I can get to that system ID via these two TLOC routes that we have available for us. And we may have more than just two TLOC routes as well, okay? It all kind of depends on what it is we're doing through the middle. Like for instance, one of the things that you can see, let me erase some of this stuff so that we can kind of see just between site 1 and site 2 in this case, okay? Not only do we have direct access through the MPLS cloud, to be able to get their MPLS ID. And not only do we have direct access through the internet to get to their internet IP address, but our service provider in MPLS might also support the idea of internet routing as well. So what we might be able to do is to go in through our MPLS cloud, out to the internet, and then be able to reach them out over in this direction, okay? And likewise, they've got the availability to be able to go to the MPLS cloud, out to the internet, and reach my public IP address and my internet connection in the other direction. Okay. So it really kind of depends on what it is we're doing within our MPLS environment at that point in time. And what do we have for internet access as well? Okay. So in this case, we would have 4 separate tunnels going back and forth between these 2 different sites that we're looking for. Okay. And therefore, 4 different TLOCs that we could potentially reach on the opposite end. So looking into some of the different components that we have to deal with here, right? They've just gone through and shown you some edge devices, but what we want to look at is the entire functionality of the components that they have in the SD-WAN solution. So what we're doing in this case, we're really breaking up the data plane, the control plane, and the management plane that we're looking for, okay? So our management plane, where do we do all of our configuration? In an SD-WAN environment for Cisco, they utilize what they call vManage. vManage is our single pane of glass, and we're going to go through and make all of our configuration changes. We have an orchestrator. The orchestrator is all about how do these guys communicate with each other. So what you're going to see is that when these edge devices come online, the first thing they're going to do is they're going to reach out to what we call vBond. vBond is our orchestrator that we're utilizing, and they're going to get authentication to vBond. vBond is then going to send them information about which of these vSmart controllers are they going to use as a primary and secondary type of controller that we have. I then make a connection up onto the vSmart devices that we're going to connect to. These vSmart controllers are learning all those routes. We mentioned the idea of the service routes and those TLOC routes that we have available for us. They're learning those from each one of these edge devices. So these edge devices are advertising that information to us. Eventually then, when another edge device joins these vSmart servers, they send all that routing information to the other edge device to then dynamically allow them to create a tunnel from one location to another location through both our MPLS cloud and our internet connection. Okay. And then it's all about our policy that we set up on vManage out over here to determine how are we going to treat this traffic? Which tunnels should we actually use back and forth between the two? So we're going to kind of go through it one at a time. Starting out over here in the orchestration plane, we said vBond is the orchestration plane that we're utilizing. They call it the vBond orchestrator, as a matter of fact. And it's going through and it's dealing with the idea of the control and management plane. I need to make sure I know how to reach the vManage and our vSmart devices that are out over here, so that when our edge devices come on and we authenticate those edge devices, yep, they're part of this company's wireless or SD-WAN environment, I can then give to each one of these edge devices the IP address of these vSmart controllers. Where do you get all your routing information from? Okay. I'm also going to facilitate the information about what vManage device you're going to be connected to. Now, this is important because these vEdge devices are going to send things like telemetry information outbound. When I go through and see traffic going from one location to another location, I always send that information outbound to vManage. Think of things like NetFlow data statistics that we're advertising. It's close. It's not exactly the same thing, but it's close. vManage typically takes that and sends it outbound to what we call vAnalytics to allow us to be able to analyze that traffic available for us. Our vBond orchestrator also goes through and facilitates things like NAT traversal. So if I have on these edge devices a private IP address, and I'm NATing, so I've got some device in the middle before we get out onto the internet, and I'm translating that to a different address. I need to know what your private address is and what your public address is. So we can match that up and say, hey, this is the exact same edge device that's out over here. Okay. They show vBond does require a public IP address, but it can sit behind static NAT, one-to-one NAT. It's typically high resistant, and it can be multi-tenant, meaning you're using one vBond from multiple companies, or it could be single tenant. It kind of depends on how big the company is going to be within here. Eventually, then we have our management plane. And in our management plane is where we go through and configure everything in the SD-WAN environment. This is where we're going to see that we're utilizing vManage. As they show, it's a single pane of glass for day 0, onboarding all of these different devices. Day 1, configuring our policy information that we have. How are we going to treat our traffic through that network? And then for day 2 and later operations, how do I go through and look at that traffic, right? How do I troubleshoot information when there's something not working? So it has a GUI interface with role-based access control. So what that really means, just based off of your username and password, you can change certain things in vManage. You may not have carte blanche being able to make any change you want within there. It is centralized provisioning. It's where we create all of our policies. And we don't want to have to just create our policies one at a time. Typically, what we're going to try and do is to create a template of those policies, something that we can reuse multiple times, over and over and over again. We mentioned the idea that we're going to be going here for troubleshooting and monitoring of all of our devices. Right? What's the health of the individual vEdge? Are they up and running? Can I reach that individual site that we have available for us? Right? That's where we're going to do things like software upgrades. I can do software upgrades for vManage, vBond, the vSmart controllers, and the edge devices if we need to. And again, it allows for third-party integration, for third-party automation with APIs like REST or netconfig, Python scripting. There's a lot of different things that we support to be able to integrate third-party software into this environment. And again, it's highly resilient, and it could be multi-tenant or single-tenant type of connections. Okay? It's where we make all of our configuration changes is in vManage. We then have the control plane. The vSmart controllers are our control plane. They facilitate things like fabric discovery. Right? What they mean by that is that when my edge devices authenticate to vBond, they're eventually then going to connect to the vSmart controllers. And they're going to register information to those vSmart controllers. Now remember, from my edge device here in the campus, I might have a connection through an MPLS cloud and a connection through the internet to be able to reach it. So I'm going to advertise my system ID that we've got on this edge device and the 2 different IP addresses on these 2 links. One goes to MPLS and one goes to internet. And that creates what we call these TLOC routes. If I want to reach this particular system ID, I've got 2 paths to get to that same destination. I eventually then advertise my services routes. Okay? These are the subnets that are at that individual location. And I'm saying to get to the subnet, you have to reach my system ID. And again, the combination of those 2 types of routes, our service route, which says how do I reach the internal subnet at that location, and our TLOC routes that says how do I get to the system ID of that particular vEdge device, are used in conjunction to be able to say how do I create tunnels to that location so we can send data across both the MPLS and the internet. It dramatically reduces control plane complexity, meaning that these vEdge devices don't have to communicate to every other vEdge device. All they have to do is to advertise their information to the vSmart controllers, which will then push it off to everybody else. I've had some people talk to me about it. Almost think of it, and it's not like it by any means whatsoever, but it's kind of similar, if you will. Okay, if you've ever dealt with things like BGP and what they call a route reflector in BGP, I am not neighbors with every other router. What I'm going to do is to share my routes with the vSmart controllers, and they will send it out onto everybody else. Right? So I don't have to have this complex routing solution where everybody's talking to everybody else. I just talk to the vSmart controllers. Okay? And those controllers then distribute that data plane information. They're going to determine what is the best route. How do we reach this location? And then the idea is that we're caching information and the Cisco Express forwarding of all of these individual edge devices of what their best routes are going to be and how do we actually configure that information. What kind of policies we're going to have. So the idea of how do we, if you're ever communicating to this particular edge device that we're looking for, right, how do we actually go through and do things like securing that traffic? What kind of encryption are we going to use? What key values are we going to use back and forth between the two? Right? What is the health of that traffic that we're going to have? And then our policy of what traffic should use which one of those tunnels that we have available for us. And again, they show they're highly resistant. However, the vSmart controllers are only single tenant. They do not support the idea of multi-tenancy. And then our edge devices are really nothing more than the data plane that we're utilizing. And they can be a physical device, okay? Like an ASR or ISR router that we have available for us. That would be known as a C-edge device that they utilize in an SD-WAN environment. Or they can be a Viptilla device, which would be a virtual device, which would be known as a vEdge device that we're dealing with. They shall provide secure data plane with remote edge routers. So once I register to my vSmart controller, those vSmart controllers send us all that routing information. And this is then when we go through and we create multiple tunnels, one through the internet and one through the MPLS cloud to reach each individual location and all the other sites that we have available for us. They show it implements the data plane and what we would call application-aware routing policies. So I'm not just simply routing, I'm now routing based off the type of application that it is. Kind of similar to the idea of policy-based routing. Right? I'm going to look at what the application is, and now based off of then our policies that we've configured in vManage, it's going to tell us how we should send that data back and forth. And what is the requirement for that data to be used on that network as well. Okay? What I want to stress is that you can make your policies in vManage so stringent that even though we have access through the MPLS and the internet cloud within here to be able to reach another location, none of them meet the policy requirements for a certain application. So you might see that that application doesn't go across, even though I can do things like ping and trace route through both of our connections. So you got to be very careful in the way that you actually configure your policies to make sure that, hey, even if it doesn't meet all of our requirements, still try that MPLS connection if you wanted to. Okay. They also export performance statistics. Right? All these vEdge devices send out their performance statistics to vManage. vManage then typically sends that out onto vAnalytics if you have it. vAnalytics is really kind of an optional thing that we have available for us. Okay. Now, these vEdge devices also use traditional routing protocols, things like OSPF, BGP, and VRRP. Unfortunately, EdgeRP is not supported just yet. Okay. They support zero-touch deployment. I don't know if I call it zero touch, but minimal touch. Right? The only thing that these vEdge devices really need to know about is the IP address of the vBond device so that we can go through and authenticate and get connection to our controllers. So that's important to recognize there as well. Then we said we have programmatic APIs. Right? So there's the representative state transfer API or REST config that we utilize, net config. And then they show it uses an HTTPS session to send data back and forth between the two. I can send gets and puts and posts and deletes as being about what we available to us. And they show that it supports authentication and authorization. We have all sorts of different bulk API calls that we can run within here by just essentially browsing to a specific site, and it'll automatically run off these bulk calls. And it also supports Python scripting as well for this third-party automation of our network. Last but not least, they talk about the idea of vAnalytics. And vAnalytics is, again, like we said, optional. It's not needed. It just gives you more of a view within the data that you're utilizing on that network. Okay, so show cloud-based analytics engine that we have. It allows for anonymization, gives me optional solution element information, gives me, again, it's an opt-in. You don't necessarily have to have vAnalytics, but it's really nice to be able to go through and analyze the traffic that we got going across that network, to come up with capacity planning that we're going to have, making sure that we're actually matching our service level agreement for every single application that we're dealing with, and for our service providers, okay? This show, it allows me to get things like U-source anomaly detection. We're seeing too much traffic going through one particular link, or too many devices connected to one single smart controller, so they can automatically go through and load balance back and forth. It gives me that application QoE that we can look into, and carrier grading as well, okay? And I can now not only go through and run analytics on all that traffic, but I can also go through and generate reports as well. My show allows me to get information. I send all the telemetry information from the vEdge devices to vManage. vManage then exports that out onto vAnalytics, where we can view this information, find out what type of traffic are we seeing. I can forecast things like, hey, this type of traffic, as we go through and do an upgrade, going to be getting more and more bandwidth being used. They can give me recommendations about what kind of policies should we use for that application to improve its performance. And finally, the idea of this what if type of scenario. If I apply this policy, how does that affect our traffic on the network, without actually applying the policy to the network just yet? Okay. Now, they eventually mention the idea of what they use for routing. As our vEdge devices connect to vMod and they get authenticated, vMod tells them which vSmart controllers are we going to be managed by, okay? So I'm going to make a connection up onto the vSmart controllers. The vSmart controllers then send routing information, and they do that routing information via what they call OMP, the Overlay Management Protocol. It's not your traditional OSPF or BGP that we're looking for. Right? Now, not to say that we can't learn this traffic fair. We can learn OSPF routes from an edge device as it comes in from the services side. And then essentially we're redistributing that into OMP and to be able to communicate that out onto the vSmart controller. The vSmart controller then advertises that route via OMP to another vEdge device, which eventually I can, if I wish, go through and redistribute it back into OSPF within here. Okay, so it's its own separate routing protocol that we look at with this overlay management protocol, because we have to add more things. It's not just a subnet and the next hop address, right? It's a subnet. To get to the subnet, you have to reach the system ID. To reach that system ID, you have to go through these different TLOCs. Right? So there's a lot of different things that we're looking for, including things like preference of the individual routes that we have available for us. They show we have a TCP extensible control plane protocol that's being used for overlay management protocol. It runs between the vEdge routers and the vSmart controllers, and between the vSmart controllers. So notice in this case right here, what I've got, they got two different sites. We're going to call this guy site number 53, and this guy site number 54 that we're looking at here, because that's just what they're showing over on this side, okay? You might have site number 53 connected to these two controllers as a primary and backup type of controller that we're utilizing. And we might have site number 54 connected to these two controllers as a primary and backup type of situation. So if I advertise a route outbound to my vSmart controller, what you're going to see is those vSmart controllers are then going to advertise it out onto other vSmart controllers. Once I've learned that route to another vSmart controller, like vSmart number 1, now I can advertise that outbound to vSmart number or vEdge device number 53 at this point. Okay? So it allows us to be able to advertise that OMP information outbound. So we don't have to have a connection to every single individual vSmart controller that's available for us. Okay? So we show the vSmarts create a full mesh of OMP peers. The vEdge routers aren't necessarily needed to peer with every vSmart controller. Typically you have 2 for redundancy's sake. And we get that information from vBond. We said, we're going to go through and I'm going to connect to vBond to do my authentication back and forth between the two. vBond recognizes, yep, you're a part of this particular company network at this point, and then sends back, here's what vSmart controller you're going to need. And what it's going to have is a list of not only the private IP address and port number, but the public IP address and port number of these vSmart devices if they're behind a NAT device. Okay? So we're going to authenticate using X.509 authentication over a DTLS connection. They then push down from vBond our controllers. Here's what controller I want you to connect to. I'm eventually then going to connect to those controllers, and they'll send me this OMP routing information. Now you're going to see, as far as the different types of routes that we have, two sides of the network as far as the edge devices are concerned. There is the transport network, and the transport side would be your internet connection, your MPLS connection that we have available for us. You'll see later on, if you keep coming back to an SD-WAN test, that they'll talk about the idea of the VPN IDs that we're utilizing. Right? They're essentially VRFs. Okay? VPN 0 is that transport network, is how we send these those OMP routes out onto the vSmart devices that we have available for us. Okay? They show traffic is always tunneled and encrypted unless we do things like split tunneling. Okay? Now, the idea is most people want the idea that it is tunneled and encrypted. Then we have the services side. And the services side would be those connections that we have down at that office. Right? They could be directly connected routes or static routes that are redistributed in an OSP or OMP, or learn via OSPF or BGP that are redistributed into OMP. Okay. And as they would show, these would be VPNs number 1 through 511 that we're utilizing. So traffic is forwarded as is from the original source at any given time. Okay? That is tunnel. Like I said, we are going to advertise what we call a TLOC route. These are transport locators. Okay? That TLOC route tells us the system IP address of the vEdge device that we have available for us. The color of the connections that we have. Is it an MPLS private connection or an internet connection that's public that we utilize? And then our IP addresses on those networks, okay? They show those OMP routes, our service-side routes, and our V routes that we have available are learned and connected through the services side. Routes are tagged with attributes in the as the OMP, and they pick up those routes, and we're going to redistribute back and forth between OMP and OSPF or BGP, for instance. Okay. Now, the TLOC isn't good enough. That just really tells us how to reach the system ID. I also need those to have those service-side routes as well. Okay? And the service-side routes allow us to be able to say, here's how I reach those internal subnets behind those vEdge. So they kind of go through and they show us our system ID. Our system IP address we have is unique identifier of the OMP endpoint that we utilize. Typically is a loopback interface that we utilize. We have an organizational name, so we have a fully qualified domain essentially that we're utilizing. And this could be a part, especially if you're utilizing things like a public key infrastructure for things like authentication back and forth between the two. All of our devices have to use the same organizational name. And then each edge device also has a site ID that identifies the location of that individual site, okay? Now, to show it's configured on every vEdge device that we have, it typically is going to be unique. Now, the only time that it is not unique is when we have two edge devices at the same physical location, right? They would use then the same site ID. The idea being is that if I'm advertising a route from my site ID, I now have two system IPs that we can reach at that site. So if the vEdge 3 goes down, vEdge 4 can reach the exact same IP addresses, the exact same service-side routes, essentially, that we're looking for. And it adds to more redundancy on that network. Now, like we said, each one of these TLOCs have a color. And these colors allow us to determine how can we communicate back and forth between the two. Do we want to allow, let's say in this case right here, you're talking about green and yellow, okay? So when we look at it, we might use for green, it might be our MPLS circuit that we've got back and forth between the two vEdge devices. And our yellow is going to be our internet connection that we're utilizing. And so we may only allow, I've got green to green, we can both reach across the MPLS cloud, that will work. You can create that tunnel. yellow to yellow, both going across the internet, that would work, okay? But then we have to decide, can I get from the MPLS cloud out to the internet to reach the other end, okay? Do we allow that green to yellow type of configuration back and forth between the two? Now, that color is very important because we can utilize it to say, hey, we don't have any internet connectivity in our MPLS environment. So you can't get from my MPLS address to the internet address on the other vEdge device. Don't try to establish that tunnel by any means whatsoever. Right? So it really kind of depends on what those colors are all about. Like we said, we'll eventually then create an IPsec tunnel between the different colored TLOC devices that are supported between the two vEdge devices. It's used to categorize it as either public or private. You'll see we have an MPLS color. There's private 1 through 6 that you can make up. There's Metro Ethernet that may not have general internet access available for it. All the other colors are considered public colors that go out onto the public internet. They show private versus public is highly significant in how we create our policy. It applies to the following: vEdge to vEdge communication and vEdge to controller communication as well, so that we make sure we can communicate to those vSmart controllers. They show based on the color settings of both edges, the vEdges know when to use public or private IP addresses as we communicate between the two different sites. Right? My MPLS circuit that we use might use private addressing, where my internet connection, going to use my public addressing, okay? As I go up on, let's say my MPLS cloud allows us to have internet access as well. So I want to establish from MPLS on one side to be an internet connection on the other side, right? Well, in that case, I want to make sure I'm using my public IP address on the MPLS cloud to be able to connect up onto the public IP address of the internet on the other end. So those colors are extremely important on how we can connect between the two vEdge devices. And so here they give you an idea. Notice that we have two separate internet connections. Nothing's really a private connection using private IP addresses. Okay? So there are 4 separate TLOCs, 2 at each location. Right? So they're showing us that we've got TLOC number 1 and 2, and TLOC number 3 and 4. And we allow connections because these guys are all using the exact same color. I allow us to be able to create a VPN tunnel from TLOC number 1 to TLOC number 3. I can create a VPN tunnel from TLOC number 2 to TLOC number 4. But because both of these are internet connectivity, you can technically create a VPN tunnel from TLOC number 1 all the way through to TLOC number 4 on the other end as well. And vice versa, I can create another tunnel from TLOC number 2 outbound to TLOC number 3 on the opposite side as well. Right? So I would essentially have 4 separate tunnels between these 2 edge devices. Okay? Now remember, these are just 2 edge devices. So we can start seeing that there'd be a lot of individual tunnels if we're in a full mesh environment. Okay? Now, by default, everything in an SD-WAN environment is full mesh. We want direct connectivity from one vEdge device to another vEdge device. Now, if you come back to the SD-WAN class, we'll show you how you can say, it doesn't necessarily have to be that way, but it could. That's just the default behavior that we're looking for. On the other side, we've got internet and MPLS, and my MPLS cloud does not have access to the internet whatsoever. So we use 2 completely separate colors in this case. For my internet connection, we're using the yellow color, and we're allowed to create a VPN tunnel from TLOC number 1 to TLOC number 3 through the internet. And for the MPLS, we're using this green color out over here, and we're allowed to create a VPN connection between TLOC number 2 and TLOC number 4. But because they don't have access back and forth between the two, they will not allow the idea of TLOC number 1 to TLOC number 4, TLOC number 2 to TLOC number 3. Okay? Those colors restrict us from trying to establish that connection back and forth. And it's typically because, like we said, we have no connection between the MPLS and the internet connection. Okay? That allows us to be able to get to that destination network. Now, they show what we're going to do is at our site, we're going to advertise our subnets, in this case, subnet A and B that we have out over here. And notice that they've assigned them to be a part of different VPNs right here, okay? If you think of a VPN as being a VRF, a virtual route forwarder. I can get from VPN1 at site 1 to VPN1 at site 2, but I can't get from VPN1 to VPN2 at site number 2. Okay, so we can separate our traffic based off of these different VPNs that we're utilizing. I'm going to send those updates out onto the vSmart controller. And as they show, I'm going to be using OMP over a DTLS tunnel. So I create a DTLS tunnel up onto the vSmart controller, and I'm then going to send these OMP routes out onto my vSmart controller. Okay. To reach these networks, you got to reach my system ID, and to get to that system ID, you can reach these two TLOCs. You're going to see the same thing happening on the other vEdge. It's going to advertise its two subnets, C and D, out onto the vSmart controllers across that DTLS tunnel. Okay. Now, when I send that to you, it's the vSmart server is also going to send me the two routes that we have for subnets A and B. They're also going to then advertise out onto this other edge device on how to reach these subnets C and D at the other location. Okay. And I'm going to advertise two different types of routes. The system routes, how to reach C and D over here, and the TLOC routes, how to get to the system IP that we have on this vEdge device. That then allows us to create these VPN tunnels back and forth between my TLOCs at each location. Once those tunnels are up and running, we're then going to send bidirectional forwarding detection to judge the healthiness of that particular tunnel. Okay, and like we said, that's going to share information about things like delay, jitter, packet loss statistics, right? Bandwidth that we have available for that, right? So how long it takes for certain applications to go across that. So give me that information, and based off of that bidirectional forwarding detection, I'm using that based off of our policy. Right? This application needs this amount of bandwidth, this less amount of delay, and this amount of jitter, and this amount of packet loss. Well, the only transport network that supports that at this point in time is transport number 1, the MPLS network, for instance. Okay, but you might all of a sudden see that across the MPLS network, we start getting a whole bunch of extra jitter. It's getting congested across there, and maybe at that point in time, through the internet, we have a better communication, and it might be best to send that application across the other tunnel at that point. Right? That's where that policy really comes into play. So that's kind of the introduction that I was looking for you guys to have. Are there any questions before I let you guys go? All right, so just making sure before anyone leaves, we have got kind of a discount on training that we have available for you guys attending our Tech Talks. So if you guys go through and log into Sunset Learning's website and use the promo code SDWANTT, you'll get 20% off the SD-WAN 300 series class, okay? Which is a really good class, as a matter of fact. Again, just throwing it out there. Does anyone have any other questions? Alrighty then, we'll let you guys go. Have a nice day.